Welcome to this video. So in this video, we're just going over assignment 2. This is Chemistry 1000. Okay. So this is for students who are doing NS at UNZA. This assignment sheet has about how many questions? 10 questions. Okay, so we are going to provide solutions to all these questions here. So we start from question 1 there. Okay, so on question 1, okay, they're saying a 1.1664 gram sample of this metal hydroxide was mixed with 25 milliliters of 3 molar hydrochloric acid and enough water added to make 100 milliliters of solution A. Okay, so they have given us the reaction involving the metal hydroxide and the hydrochloric acid. Okay, so the question continues. They are saying a 10 milliliter aliquot of solution A was taken and titrated with 20 milliliters of 0.175 molar of sodium hydroxide. Okay, they have also given us, they've also given us the reaction, okay, involving the sodium hydroxide and the hydrochloric acid there. Okay, so now they're saying give the identity of M using stepwise logical reasoning. Okay, so how can we give the identity of M? Okay, simply we have to calculate its molar mass. Okay, we have to calculate its molar mass. So how are we going to calculate this molar mass here? Okay, first of all, we need to identify that this question here is a question on what we call as back titration. Okay, titration. So in a back titration, the idea is that, okay, you are given two chemicals or two reactants. Okay, let's say reactant A and B. Okay, and then one of these reactants here will be in excess. Okay, so meaning that once these two react, okay, one of those reactants is going to remain. Okay, so let's say, for example, our reactant B is the one that is in excess. Okay, so A and B react quite all right. They form their products, maybe D and C. Okay, so after they form their products, because this reactant B was in excess, okay, some of it is going to remain. Okay, so what do we do with the B that remains? You react it with another substance, let's say F. Okay, and then these reacts and then they'll form products, maybe G and H. Okay, so that's the basic idea in the back titration. Okay, you are given two reactants, one of them should be in excess. Okay, so after the first reaction, some of that reactant remains. Okay, and then it's that the reactant that remains, okay, is gotten and then it is reacted with another chemical to produce other products. Okay, so in this case, how do we know which one is our excess what reactant or excess chemical? Okay, so just take a look at the equations that you've been given there. The one that appears in both is the one that is in excess. So here we can see that HCl is here, okay, and then HCl is there again. So here it means that the hydrochloric acid was in what? In excess, okay? So if I could draw what is happening here, we have this situation, okay? If this is a beaker like this, okay, I have this metal hydroxide. I'll just represent it by these yellow boxes. Okay, this is our metal hydroxide or M hydroxide. And then to this hydroxide, let's add the hydrochloric acid. Okay, so add the hydrochloric acid here, the one I'm putting in blue. Okay, so these two, this metal oxide, hydroxide in yellow, and the hydrochloric acid here, okay, the metal oxide and the hydrochloric acid, they react. Okay, when they react, they're going to form products. Okay, but because this hydrochloric acid is in excess, okay, some of it is going to remain here. So this is the hydrochloric acid that has remained now. Okay, and then what do chemists do? Okay, they will get this excess reactant that has remained. Okay, they're going to react it with another chemical. Okay, so in this case, the other chemical is what? Sodium hydroxide. So let's draw the sodium hydroxide in white like this. Okay, so this is my sodium hydroxide there. Okay, so this sodium hydroxide is going to react with the excess hydrochloric acid from the what? From the first reaction. So this is our first reaction. Okay, and then you get the excess, you react it with the sodium hydroxide. Okay, this will be our second reaction. So when making calculations, okay, for a back titration, you mostly start with the what? The second reaction. Okay, and then from the second reaction, you're just going to be going backwards like that. No wonder it's called the what? A back titration. Okay, to find whatever you want to find here. In this case, our aim is to find the molar mass of what? This metal what? M. Okay, so our calculations will begin from this one here, this reaction. Okay, so let's do that. Okay, so the second reaction there, we have sodium hydroxide, okay, reacting with the hydrochloric acid. Okay, and then here we've been given the volume and the molarity of the sodium hydroxide. So we know that molarity is equals to, okay, moles over volume. Okay, so we can cross multiply here, or we can make moles the subject. Okay, if we make moles the subject to just be mv. Okay, so this volume here, I should mention that it should always be in liters. Okay, this one should always be in liters. So if you have been given volume in any other units, make sure you convert it to what? To liters or cubic decimeters. So moles is equals to molarity times volume. So we can use this formula here to find the moles of what? Sodium hydroxide. Okay, so we're going to say moles of sodium hydroxide are going to be equals to, okay, the molarity 0.1750 multiplied by, this here is the volume, but it has been given in what? Milliliters. So we change this milliliter to liters by dividing by what? 1,000, like this. Okay, so when we divide there, what are we going to find as our number of what? Moles. Okay, so when I divide there, I'm finding 0.0035 moles. Okay, so these are the moles of sodium hydroxide. In this second reaction, remember we said this is our first reaction, this is our second reaction. So in our second reaction, these are the moles of sodium hydroxide. Okay, and then we know that from this reaction here, we can get a mole ratio between the sodium hydroxide and the hydrochloric acid. The mole ratio there is 1:1. Okay, you can see because this reaction here is balanced. So what does that mean? It means the number of moles of sodium hydroxide will just be equal to the number of moles of what? Hydrochloric acid, because the mole ratio there is what? 1:1. So we are going to say since, okay, we're going to say since the mole ratio is 1:1, okay, it means the moles of sodium hydroxide are equal to the moles of hydrochloric acid, which will just be what? 0.0035 moles. Okay, so it means here we found the number of moles of hydrochloric acid in the second reaction. Okay, in the second reaction. But remember, our question said a 10 milliliter aliquot of solution A. Initially, solution A had this volume. Okay, it had 100 milliliters. And then now it's what? 10. They have just gotten a part of it, which is 10 milliliters. So it means these moles here are in what? 10 milliliters of that solution. Okay, so before we can use these moles anywhere, okay, we have to make sure that we find the moles in what? The 100 milliliters there. So what are we going to do there? Okay, we're just going to use more like a ratio. Okay, we are going to say in 10 milliliters, okay, I have these moles. What about in 100 milliliters? How many moles am I going to have? So you cross multiply, you're going to have 10x is equals to this multiplied by that. Okay, it will just be 0.35. Then divided by 10, divided by 10 means x will be equals to 0.035 moles. Okay, so these here are the moles, okay, in 100 milliliters of solution A. And these moles here, we've gotten them from where? The second what? Reaction. So it means these moles, okay, are the excess moles of the hydrochloric acid, okay, that went to react in the second reaction. Okay, remember we said we have two reactions here. So these are the excess moles of what? Hydrochloric acid. So we can write it here. Okay, we are going to use it. So we can say the excess moles, okay, of hydrochloric acid. Okay, excess moles are just equals to 0.035 moles. Okay, so these are the excess moles of hydrochloric acid, or the moles that reacted in the second what? Reaction. Okay, and then from there, okay, we need to find um, the moles that reacted in the first reaction. Okay, so how are we going to find the moles that reacted in the first reaction? Okay, so it's simple. You just have to find, first of all, the initial moles of hydrochloric acid using this information here. And then once you have the initial moles of the hydrochloric acid, okay, we are going to say the moles of hydrochloric acid that reacted here will just be the initial moles minus the moles that reacted in the what? The second reaction. Okay, so we're going to say initial here. Okay, the initial moles of hydrochloric acid. So this will be equals to, so we have the volume and the molarity. So it's just 3 multiplied by that volume, but make sure it's in what? Liters. Okay, so when I find that volume, I'm finding 0.075 moles. So these here are the initial moles. Okay, before any reaction occurred, these are the initial moles of hydrochloric acid that we had. And then we also found that the ones that reacted in the second reaction were these. Okay, so it means now we can use this and this to find how many moles reacted in the what? The first reaction there. Okay, so we're going to say moles of HCl that reacted in the first reaction are going to be equals to the initial moles minus these moles here that reacted in the second reaction. Okay, so when I subtract there, what am I going to get as my moles? Okay, so I'm getting 0.04 moles. Okay, so it means in the first reaction, okay, so I had this, okay, I had these moles, and then they reacted with the metal hydroxide, okay, a part of those moles reacted with the metal, okay, so those moles that reacted with the metal are these 0.04. Okay, and then the remaining ones are these ones that went on to react in the what? The second reaction. Okay, so once we have now the moles that reacted in the first reaction, it means our question even becomes simpler because we can use the mole ratio here to find how many moles of this reacted. Okay, so we are going to say from this balanced chemical equation here, this one is already balanced. We're going to say 1 mole, okay, of the metal hydroxide reacts with 2 moles of hydrochloric acid. Okay, so what about if I have 0.04 moles? How many moles here am I going to have? So you cross multiply, you're going to get 2x is equals to 1 multiplied by 0.04, it's the same. And then we want to find the x there. So you divide both sides by 2. So it means x is equals to 0.04 divided by 2, and this will give you 0.02 moles. Okay, so these moles here are for what? The metal hydroxide, like this. Okay, so it means these are the moles for the metal hydroxide. Okay, so remember we said our M here was calculating the molar mass of M, right? Okay, so we can calculate the molar mass of M by first calculating the molar mass of this whole metal hydroxide. Okay, so how can we calculate the molar mass of a metal hydroxide? Okay, we have the moles of it, and then in the question we've been given the mass. So we can use moles is equals to mass over molar mass. So we want to calculate the molar mass, we make it the subject to be molar mass is equals to mass over moles. So we're going to use this formula here. Okay. Okay, so let's use it. So we're going to say molar mass of this whole metal hydroxide is just the mass 1.1664 divided by the moles, which is 0.02. Okay, so when you punch this onto your calculator, should give you 58.32 grams per watt per mole. Okay, so this one here is the molar mass for this whole thing here. Okay, so how can we use it to find the molar mass of this? Okay, so we know that the total molar mass is just the addition of the individual molar masses there, right? Okay, so we can use that concept to find the molar mass of metal M. And then once we find the molar mass of metal M, it means we would know its identity. Okay, because just go on the periodic table to check an element that has that same what? Molar mass. Okay, so here it means this 58.32 is gotten by adding the molar mass of M plus, okay? And then here I have oxygen and hydrogen, okay? So we are going to say the molar mass of oxygen is 16, okay? And then plus the molar mass of hydrogen is 1.01, okay? And then these ones here, we are multiplying them by 2 because there's this 2 outside here, okay? And then this should give us this 58.32. Okay, so it means M plus, okay, so this here will be like 17.01. So 17.01, and then we multiply it by 2 is equals to 58.32. So this will be M is equals to, okay, when you multiply 17.01 with 2, you are going to get 34.02. So now you take it to the other side. So it will be 58.32 minus 34.02. Okay, so this here will give me 24.3 grams per mole. Okay, so this is the molar mass of this metal M. Okay, this is the molar mass of metal M. So you just go on your periodic table. Okay, you check which element has a mass that is closer to this 24.3. Okay, so when you go on your periodic table, you're going to find that the one that has the molar mass closer to this is just magnesium. Okay, so that's how we can use the back titration, okay, to identify the metal what? M. Right, so we are done. So in case you'd like to access the full solutions to this assignment, okay, you are welcome to register with us. You can check the link in the description there. Okay, so you're going to find 2 links. One of them has a video showing you on how you can register with us, and then the other one is a link to the website where you register. Okay, so once you register, you'll be able to find full solutions, okay, to all these questions that you can see here. All right, so once you get registered, okay, and then you log in on our website, you're going to see something like this, okay? So on the course where you are enrolled, you see enrolled there. If you're not enrolled, there will be not enrolled on top. So since this was a chemistry assignment, let's go to the chemistry folder there. We open it, we see what we have there, okay? So what do we have there? Okay, it's loading. So you go to the general chemistry, okay, because you are from UNZA. So you go there, general chemistry. Then once the general chemistry opens, okay, you're going to find 4 folders. There's lessons and tutorials. So there we have videos on each topic and notes, okay. And then here there's handwritten notes, very summarized, very direct to the point. You can access them and you will learn better, okay. And then there are tutorial sheets and assignments. There are past papers. Here there are some lab report samples that you can use for your labs, okay. So that was an assignment, right? So you go in the assignments folder here. So just click on the assignments folder there. Okay, wait for it to open. Right, so when you are there, you are going to find different universities here. So you go to your university, okay? So you're from UNZA, you click UNZA. Okay, so you're going to find these tutorial sheets. So we have tutorial sheets for 2022 intake, 2023, 2024. So you can use all these tutorial sheets to learn. Okay, so you can just go there, you try out a question, okay, you solve on your own, then you compare with the answers there because there are solutions there. Okay, and so for you, okay, for this assignment, you can go to the 2025 intake. Then when you go to the 2025 intake, you're going to find written and video solutions there. Okay, so the video, I'll upload them here. Okay, the written, you upload them there. So if you go to the written here, you're going to find the ones that we have uploaded. Okay, so there's tutorial sheet 1 for chemistry 1000. Okay, you can access it there, full solutions. And then even for the assignment, it's there, you can see it. Okay, so we'll also upload all the other assignments that you will have, okay, during the course of this whole academic year. Okay, it's just not this assignment, but all the assignments that you're going to have, will be uploading them here. Okay, even for those who are taking chemistry 1010, we'll be uploading them here. Right, so you can click on the assignment to open it. Okay, it should load there. Right, so it took a bit of time because of the network issues, okay, but it should, if you have a good network, you should just open instant. So these are the solutions there. Yeah, so these are the questions, and then down there, you're going to find the solutions here. So we'll explain solutions for you. These, just like I was explaining, identify the metal, it's magnesium. You go to question 2, just like that. Okay, so you can access the full solutions on our website. Okay, so you can register at only 100 kwacha per course per month. And the good part is that 100 kwacha per course per month, it's not just for this assignment. Okay, it's for all the assignments that you're going to have in that month. All right, so feel free to register with us and learn easily. All right, so thank you so much for watching and have a blessed night.